So this topic is called quadratic relations in factored form. Factored form. That's not vertex form. It's also not standard form. It's going to be our third form of our quadratic relations. So before we can really truly understand this, let's do a little bit of investigation. So we see here we have a relation y is equal to 2 times x plus 1 times x minus 3. Now, what we're going to do is we're going to complete the graph here, and we're also going to do our first and second differences to see what we can see what actually happens here. Now, that means that for our first term, we have an x of negative 2. We're going to substitute that negative 2 into this equation and figure out what our y value is. You're like, wow, that is a lot to keep in mind. Well, let's do 1, and then we'll switch it over to mental math. So if we're thinking about this, this is the same thing as y is equal to 2 times our x value, which is negative 2, plus 1, multiplied by negative 2 minus 3. So if we have negative 2 plus 1, that's just negative 1. So 2 times negative 1, we're at negative 2. And then we have negative 2 minus 3, that's negative 5. Negative 5 times negative 2 gives us 10. Oh, yeah, we can still do this in mental math. We just have to know where it's coming from. So now we're going to substitute the negative 1 in here. Negative 1 plus 1, that's just 0. Well, 0 times anything, we're multiplying nothing but 3 terms here, so 0 times anything is going to give us 0. I don't even have to do any more work. I'm done there. All right, so we have a 0 in here. 0 plus 1, that's 1. 0 minus 3, that's going to be minus 3. So we have 1 times negative 3, that's negative 3. Times 2, that's negative 6. Okay? If you need to, slow down and write it out so you can actually see where the math is coming from. Okay? We're going to substitute this 1 in here. So we have 1 plus 1, that's 2. 1 minus 3, that's negative 2. So we have 2 times negative 2, that's negative 4. Times 2 is negative 8. Okay? We're going to substitute this 2 in here. 2 plus 1, that's 3. 2 minus 3, that's negative 1. So we have 3 times negative 1, that's negative 3. And multiply that by 2, we have negative 6. Oh, looks like we found our point of change here. Now we substitute our 3 in here. 3 plus 1, that's 4. 3 minus 3, that's going to give us 0. 0 times anything is going to give us 0 again. That shouldn't be a surprise. All right, so we can graph this in, and then we'll fill out our first and second differences to try and figure out what is going on here. So we have negative 2 and 10. Negative 2 and 10. So negative 2 all the way down here at, all the way up here at 10. Negative 2 and 10. All right. Negative 1 at 0. Oh, that's a big change. 0, negative 6 down here. And 1, negative 8. And 2, negative 6. 2, negative 6. And then 3 back up to 0 again. And if we went 1 more, we'd end up with 4 all the way up at 10 again. So let's graph this in to the best of our ability. And we got to fill it out. Y is equal to, label everything clearly, x plus 1 times x minus 3. Okay, let's fill out all of our data now. We can see it. Looks like a pretty standard relation, nothing weird about it, which is interesting because there's no x squareds in there. But there would be if we multiplied this through and expanded. If we multiply it and we FOILed these two terms, we'd end up with an x squared in there. Anyways, so let's see this. So find our first differences. So 0 minus 10, that's going to give us negative 10. Negative 6 minus 0, that's negative 6. Negative 8 minus negative 6, that gives us negative 2. Negative 6 minus negative 8, that's going to give us positive 2. And 0 minus negative 6 gives us 6. So definitely not linear. So let's check out our second differences. Negative 6 minus negative 10, that gives us 4. Negative 2 minus negative 6, also 4. 2 minus negative 2, 4, and 6 minus 2 is also 4. So this is second differences are constant. That tells us that it is a quadratic relation. So that's good news. We can see the quadratic here. All right, let's keep going. State the x-intercepts of the parabola. So where does it touch the x-axis? Well, it touches it at -1 and +3. So -1 and +3. Or we could write it as their actual coordinates, which is -1, 0, and 3, 0. So that's where it actually touches the x-axis. How do the x-intercepts relate back to the equation? So we have -1 and 3. Let's go back up here. So here's the original relation. Do -1 and 3 look like they relate? Yeah, kind of. If you look at that, there's the 1 and there's a -3. So they're pretty much the same, except the opposites, the values have the opposite sign. Okay, so that means, how do they relate? Well, it's the opposite values that are inside the brackets. Opposite values that are in the brackets. How does this help us? Well, let's keep going. Maybe something will jump out. Where is the axis of symmetry? Well, if I follow this, I can see that it jumps up this line right here. So I can see the axis of symmetry is going to be x is equal to 1. Now this is all just visual. I don't have any math to support this right now. It's just me looking at the curve. Well, how can the x-intercepts be used to find the axis of symmetry? Remember what symmetry means. It means it's the same on both sides. That tells me that the left x-intercept and the right x-intercept are exactly the same distance away from the axis of symmetry. So the distance from here to here and the distance from here to here is exactly the same. Great. What does that mean? That means it's a midpoint. It's a midpoint between these two values. The axis of symmetry tells us exactly where the midpoint between our x-intercepts are. So we can find the midpoint of our x-intercepts. So then we can actually do it mathematically instead of just eyeballing it and saying x is equal to 1. Midpoint of our x-intercepts. Well, how do we find midpoint again? Add them up and divide them by 2. So that means x is equal to our -1 plus our 3 divided by 2. -1 plus 3, that's 2. 2 divided by 2, that's just a 1. Oh, that's exactly what we got. So we mathematically found our axis of symmetry. Well, where's the vertex? Well, the vertex is way down there, and I can see that that's at a value of 1, -8. Again, we're kind of eyeballing it. We know the 1's accurate, but what about the -8? We're kind of assuming. Well, how can we get extra information? How can we actually mathematically do this? How can the axis of symmetry, x is equal to 1, be used to help find the vertex? Well, if we substitute the value of x is equal to 1 into the original equation, we're going to calculate what the y value for x of 1 actually is. This tells us that we can actually get the y value of the vertex. So we are going to sub in the axis of symmetry, sub in the axis of symmetry. In this case, x is equal to 1 into the original relation. This is nothing new. We've been calculating components of coordinates all semester long by substituting one value into our equations to figure out what the other value is. In fact, we did it in just the last lesson. But anyways, so what that means we have y is equal to, we're going to put x is equal to 1 into our equation. So 2 times 1 plus 1, and then multiply that by 1 minus 3. So that's 2 times 1 plus 1, that's 2. And 1 minus 3, that's -2. What we end up with is -8. 2 times 2 is 4. 4 times -2 is -8. All right. So now we know that the x component is 1 and the y component is negative 8. So now we've just verified that the vertex is indeed 1, negative 8. Okay. So this is where all this information comes from. How can we actually use this and generalize it going forward? All right, so here's the plan. Whenever you see an equation like this, the quadratic relation in the form y is equal to a times x minus r times x minus s, this is what we call the quadratic relation is in factored form. Why is it called factored form? Because that's a factored relation. We can see that it's multiplied here. Okay, so what does that mean? We have 3 different types of quadratic relation equations now. The first type is our standard form. What does our standard form look like? It looks like this. Y is equal to ax squared plus bx plus c. If you multiplied and expanded your equation here, you would end up with your standard form. So just by expanding factored form, you're going to end up at standard form. Okay. The second form that we learned was the vertex form. Now this is the one that helped us when we know exactly the vertex and ideally one more point, and we can solve for pretty much anything in that case. So y is equal to a times x minus h squared plus k. And then what we just learned right now is factored form, which is y is equal to a times x minus r times x minus s. And you're like, what is r and s? Where did those come from? Well, I'm glad you didn't quite ask, but are actually really asking. So let's go break it down and summarize everything that we just learned. We still have an a term. How does a affect this entire relation? The exact same way it's always affected it. So the a value affects the graph. Effects the graph in the same way as vertex form, which means a is it'll tell us whether it is reflected. It will also tell us whether it's been stretched or compressed. Now, it will actually do this, and we don't have to do anything special to actually make that show itself, but it will. What about R and S? Well, where did those come in over here? Those told us our x and y our x-intercepts. So the R and S values are the x-intercepts. Well, if you look at this, this is clearly a times x minus r. Well, this is x plus 1, so to get the plus, we have a minus times a minus. So that means our x value is negative 1 for our first x-intercept. Over here, we had minus 3. So the sign didn't change, which means the sign is actually a positive. Okay? So x minus r, x minus s. Great. Where was I? Pardon me. So how do we find the axis of symmetry? Well, the first thing we have to do is we have to find the midpoint between our two x-intercepts, which is just x is equal to r plus s divided by 2. Okay? Now, once we have that, we can actually determine the vertex by taking that midpoint and substituting it back into the original equation and calculating for the y value. Okay? So to find the actual vertex, we know the x component is r plus s divided by 2, and then the y component. But the y component is found by just substitute in the value of the axis of symmetry, r plus s divided by 2, for x to find the y value. Now, where are we substituting it? Substitute the value for x into the relation. Okay? In order to find our axis, our vertex. Great. So let's go put it into practice. So in this one, there we go. So in this one here, we're given the relation and we're given a table to fill out, but we're not given any table of values or anything like that. We just got to do the work. So let's fill out the data that we know. We have y is equal to a times x minus r times x minus s. So what direction is it opening, up or down? Well, that's a negative a, so it's opening down. All right. What are the x-intercepts? So the x-intercepts are going to be the opposite of what we see here. In this case, the x-intercept of 2 is going to be, or x plus 2 is going to give us negative 2. And over here, we're going to have positive 6. So our two terms, our two actual coordinates, sorry, are 2, negative 2, sorry, 0, and 6, 0. So we can actually put those on our graph right now. So negative 2, 0, and 6, 0. Alrighty. What is the axis of symmetry? We got to find the midpoint. So x is equal to the first point, which is negative 2, r plus s, which is 6, over 2. Negative 2 plus 6, that's going to give us 4 divided by 2. That's just going to give us 2. So our axis of symmetry is right down x is equal to 2. Okay. What about the vertex? How do we get the vertex? Well, we're going to substitute our 2 into the original equation for x, and we're going to solve for y. Whew. All right, let's see. Y is equal to negative 1 over 2. And then inside of the brackets here, we have our x value of 2 plus 2, bracket 2 minus 6. So let's leave that negative 1/2 there for a second. And then we have 2 plus 2 is 4, and 2 minus 6 is negative 4. So that means 4 times negative 4, that's negative 16, times the negative half is going to give us exactly 8. So that means our vertex is located at the x component of the axis of symmetry, which is 2, and the y component we just solved for, which is 8. So I can now put that in there, 2, 8. And that's all I need. Now I'm just going to draw the curve in. Now I'm only working with 3 points here, so it's not going to be as precise as what we're used to, but it still follows the curve that we're expecting. Y is equal to negative 1/2, x plus 2, and x minus 6. And that's all there is. So let's do it again. So we're looking at the equation here. Y is equal to negative 2 times x minus 1 times x plus 2. Our a value is a negative 2, so it's going to open down. Okay. Our x-intercepts are the opposite signs. So we have 1 and we have negative 2. Those are our two x-intercepts, which are located at 1, 0 and negative 2, 0. So 1, 0 and negative 2, 0. Does it matter what order they go in? No, of course not. Now, I want to find the axis of symmetry, which means I have to find the midpoint. X is equal to 1 minus negative 2 over 2. So 1 minus negative 2, that's the same thing as adding. So that's, did I get that right? Yeah, I think my notes are a little bit off. Yeah, I think my notes are a little bit off. So this should be 1 minus 2. I think that's right. Oh, what was I doing? Why was I subtracting? It should be adding. Silly me. There we go. 1 plus negative 2. That's going to give us negative 1 over 2. Negative 1/2. Or negative 0.5 if that makes it easier for you to actually draw it on there. So now we're going to substitute that into our original relation to try and solve for our equation here, or solve for our y value. So that means we have y is equal to negative 1/2 multiplied by our x component. Our x component is negative 1/2 plus, actually in this case, minus 1 multiplied by negative 1/2. Can't read that at all. Need more space. There we go. Multiplied by negative 1/2. And then we're going to add on 2 plus 2. So a little bit of mental math here. We have negative a half minus a half. That gives us negative 3 over 2. So negative 3 over 2. And we're multiplying that by negative 1 half plus 2. So that's 2 over 2. So negative 1 plus 2 over 2, or sorry, 4 over 2. Negative 1 plus 4, that gives us 3 over 2. So what did we end up with here? What do we actually get? We have negative 1 times negative 3 gives us 3 times 3 gives us 9. 9, okay? And we end up with 9 over 2. 9 over 2? Yes, 9 over 2. There we go. Oops. I think I made a mistake here. Where am I? This is the right answer, but that's just because I was looking off my solutions. This is not mathematically accurate because this would give us negative 9 over 8, and that's definitely not what we're looking for. So let's back this train up a bit. I can see where the problem occurred. So we're going to erase this entire component here. And that's because of this guy right there. We put in the wrong a term. By we, I mean me. The a term should be a negative 2. That's better. So now we have y is equal to negative 2 multiplied by negative 3 over 2 multiplied by 3 over 2. Now when we look at it, we end up with negative 3 times 3. That's going to give us negative 9 over 4. Times that by 2, we end up with 18 over 4, which then does indeed become 9 over 2. So therefore, our vertex is located at our x value of negative 1 half, comma, 9 over 2. Or negative 0.5, comma, 4.5, however you want to put this. So I can put this in here. So negative 1 half and then 4.5 right in the center, right about there. And then our job is to connect the dots. Boom. And label everything. Sorry, I was just in too much of a rush there, and I made a mistake. That's why I had to backtrack. I apologize. So let's make up for that on the next question, shall we? So in this one, we have to determine the relation in factored form. Vertex form wasn't too bad because we just looked at the vertex and we had to change our solve for our a value and everything like that. So let's see if anything changes when we're talking about factored form. So first up, we need to know, remember our equation is y is equal to a times x minus r times x minus s. So that means we really need to find a, r, and s. So what are r and s? R and s are our x-intercepts. So we can just look at this and we can see what they are. We see one right here and we see one right here. Now I know it's a little difficult to see, but that's at negative 1 and this is at 3. So that means that r is equal to negative 1 and s is equal to a 3. So our x-intercepts, if we need to know them, are negative 1, 0, and 3, 0. Okay. But what about the a term? Do we know anything? We have to find it. Now, the thing is, we can find this in the exact same way that we did last time. First of all, let's substitute our r and s into our equation. So we have y is equal to a, which is unknown right now, x minus r. So that's x plus 1. X minus negative 1 gives us x plus 1. And then x minus s, which is x minus 3. Nothing changes there. So what can we do with this? Well, we can substitute. What can we substitute? We need a point. Do we have any points other than our x-intercepts? Well, we can kind of see that the vertex up here, we could calculate what the vertex is if we need to be specific, but we can see what the vertex is. And that vertex is at a location of 1. And if you count up, it's going to be 1, 8. So if we substitute this point into our equation, so sub 1, 8 to find a, we should be able to find our last term that we need. So our y value is 8 equals a times our x value, which is going to be a 1, 1 plus 1 times 1 minus 3. So we have 8 equals a times 1 plus 1 is 2 times 1 minus 3 is negative 2. So that's 8 is equal to negative 4a. So that means a is going to be equal to 8 divided by negative 4, which is negative 2. So therefore, our final equation is y is equal to negative 2 times x plus 1 times x minus 3. There we go. So not too bad. It's pretty much exactly the same as last time, except we're not working from the vertex. We're working from the x-intercepts. We still have to be able to see things in the graph, though. So let's try again. This one's a little bit more challenging. The numbers aren't exactly the way we want them to be. So looking at this next curve, what do we got here? Well, we need to determine the relation in the factored form still, so nothing's really changing here, but what do we know? We know that we need to start with y is equal to a times x minus r times x minus s. Pardon me. So where are we hitting the x-intercepts? When we can count over, we can see right there. That's at location, looks like 1, 0. And over here, it looks like we're at negative 5, 0. So that tells me that r and s are equal to, let's say, 1 and negative 5. Okay. So let's substitute those values in. So now we have y is equal to a times x, our r is a 1, so x minus 1, times x minus our s, so minus negative 5, so that's x plus 5. Okay. Now what? Well, we still need to get our a, so we need another point so we can substitute in. And we can see that the vertex down here, it's pretty straightforward. That's at negative 2, negative 4. So we're going to substitute that one in there. So negative 4 is equal to a times our negative 2 plus, or sorry, minus 1. It's erasing the wrong things. Get rid of that guy. Whatever. So let's try this again. Our x value is negative 2. And this time we want to minus 1. And this one's going to be negative 2 plus 5. Substitute all this stuff in. We got negative 4 equals a times negative 2 minus 1. That's negative 3. Multiplied by negative 2 plus 5. That's going to give us positive 3. So that's going to give us negative 9. So negative 4 is equal to, pardon me, negative 9a. So that means a is going to be equal to 4 over 9. Not the nicest term in the world, but that doesn't mean it's wrong. So therefore, our final equation is y is equal to our a value, which is 4 over 9, times x minus 1 times x plus 5. And there's our final equation. Again, it still works, even if the numbers aren't as nice as we would like them to be sometimes. Everything is kind of taking its time here. Alrighty. So with the next piece, what we're going to do is we're going to, as it says here, we have a parabolic gate. So this one, we got a word problem now. So we got a parabolic gate is built 20 meters tall and 22 meters wide from the left post. From the left post. So who knows where the left post is? Maybe the left post is right at 0, 0. Maybe it's over here. I don't know. We'll come back to that in a second. So a parabolic gate is built 20 meters tall and 22 meters wide from the left post of the gate. Oh, which is located 4 units left of the y-axis. Okay. So that means the left post is right here at location negative 4, 0. Okay? So negative 4, 0. And the right post is 22, it's 22 meters to the right. So that means it's going to go all the way over to the right-hand side, 22 meters past negative 4. So that's going to be a positive 18. So let's see, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, how convenient. The whole graph. So there's our second point, which is at 18, 0. Great. We know that the whole thing is 20 meters tall. That tells us a maximum. Well, where does our maximum exist? Our maximum exists at our vertex. So that means the y component of our vertex is 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 is going to be right there. Now where that is, well, we got to find the midpoint, right? So state the x-intercepts. Well, that's clear. We can see that the x-intercepts are going to be negative 4 and 0, as well as 18 and 0. State the axis of symmetry. We got to find the midpoint. So that's negative 4 plus 18 divided by 2. Negative 4 plus 18, that's 14 divided by 2. That equals 7. So our axis of symmetry is x is equal to 7. Okay. So 1, 2, 3, 4, 5, 6, 7. So right there. Now if we follow this all the way up, there's our axis of symmetry. State the vertex. Well, we know that it is located at x of 7 and the y value. Now I don't have an equation, so I can't really do much else, but I do know from the problem that its maximum height is 20. So that means that our vertex is right here at 7, 20. We have to read the problem. Find the relation to the model to model the situation. So what we're going to do is, because we have the two x-intercepts and we have a vertex, the perfect thing to use is going to be factored form. Okay. Could we do vertex form? Well, it'd be a little bit more tricky, but yes, in theory. But let's deal with factor form here. So we have y is equal to a times x, now minus negative 4. So that's going to be x plus 4. And then x minus 0. Or sorry, minus 0, minus 18. There we go. So that gives us the startup, but we need to get the a term. And we get the a term by substituting a value in. The only other value we know other than the x-intercepts is the vertex. So we're going to substitute that in. So that means a y value of 20 equals a times our x value, which is 7, plus 4, times our x value, which is 7, minus 18 again. Okay, substitute. 20 is equal to a times 7 plus 4, that's 11, times 7 minus 18, that's going to give us negative 11. We can do our math here. We can do this. 20 is equal to a times, well, what's 11 times 11? That's 121, but it's negative, so negative 121. That means a is going to be equal to 20 over 121. Sorry, negative 20 over 121. So what's the relation? Y is equal to negative 20 over 121 times x plus 4 times x minus 18. There we go. What's the y-intercept? Whoa, what? What's the y-intercept? Interesting. So how do we find the y-intercept? Well, to find the y-intercept, that happens when x is exactly equal to 0. So all we have to do is substitute a value of 0. So sub x equal to 0 into relation. All right. So we have y is equal to negative 20 over 121 times 0 plus 4 times 0 minus 18. Okay, I'm going to scroll down a little bit so we can see everything. Does that come out to a nice number? Not really. It doesn't. So it's going to come out to y is equal to approximately 11.9. But that doesn't make it wrong. So let's graph this in. Now I know that it's going to hit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So just below here, right about there. So this will help me give a more accurate value. So I can do the same thing over here, right there. And now I substitute, or now I graph, not substitute. Wow, that was impressively terrible. Okay, so now we have we can label our relation and finish that off. So we have our y-axis, our x-axis, that's all done, but we have to label everything else. Y is equal to negative 20 over 121 times x plus 4 times x minus 18. And there's our entire relation. Graph the model. Check mark. We did that. Is there anything else that we need to do? No, that's going to be it. So that's the end of this lesson. Basically what we did here is all about factored form. We broke it down into the r and the s, so that allowed us to find the x-intercepts. We used that. We found the midpoint between those to find the axis of symmetry. We substituted the axis of symmetry into the original relation to find the y value of our vertex, and that gave us everything we needed to solve problems as well as create a full relation for our curves. And that's it for this lesson.